Filtering noise out of a signal is an important part of signal management. If this is not done, music, like signals, is muddled and the information is hard to extrapolate. The human ear has a range of about 20 Hz to 20 kHz. A musical instrument, like the piano, has a range of about 32 to 4200 Hz. Most music tends to be in a range of about 65 to 2000. This means that if we want to enjoy just some music, we should remove all frequencies outside this range as it is noise. The same principle is true of signals. Let us take this signal. It has a formula that describes it, but like the music at the beginning of this video, there is more information in this signal than we want. It has noise. Let us transform it from the time domain to the frequency domain. Mathematically, this is called a Fourier Transform. Like with the music, we only want to receive a small section from these frequencies, so we want to remove the rest. In this case, we want everything from 60 to 120 Hz. Let us start with a high-pass filter to remove the frequencies below 60 Hz. A high-pass filter allows the high frequencies to pass while removing everything else. It's a bit like how a red filter allows the red light to pass through while removing everything else. Then we have a low pass filter to remove everything above 120 Hz, and the final filter will isolate the signal we are after. It is known as a band filter. Now the signal can be converted back to the time domain fairly easily, and we can clearly see the filtered signal. Now we only have the information that we need, and all that noise has been removed. So, how is this done in the real world, particularly electronics? The most simple circuit is called a passive RC filter, otherwise known as an RC circuit. It consists solely of one resistor and one capacitor, hence its name. Interestingly, this one circuit can do both the high pass and the low pass filter. If the voltage across the resistor is measured, it will show the trace of a high pass filter. This can be seen by varying the input frequency. As we see, the lower the input frequency, the less the amplitude of the output signal. If, however, we decide to measure the voltage across the capacitor, we see the opposite effect. In this configuration, the RC circuit is behaving like a low-pass filter. The higher the input frequency, the lower the amplitude of the output signal. So, let's take this to the next level. This RC circuit also works with multiple frequencies. Now, unfortunately, I only have a limited number of signal generators, so I'll only use two. One of them will generate a low frequency of about 760 Hz, and the other will generate a signal of 1.65 kHz. As this RC circuit has a cutoff frequency at about 1.59 kHz, the filtering effect should be obvious. First, let's measure the output across the resistor. The yellow trace is the input signal and the blue is the output. When we read the voltage across the resistor, the high frequency remains while the low frequency is almost gone. If we reconfigure the circuit so that the voltage is measured across the capacitor, we see the effect of the low pass filter. The high frequency has been removed while the low frequency is now quite apparent. So as you can see, filters are rather important and useful and are quite easy to build. I hope you liked the video and I wish you the best for the rest of your day. Thanks for watching.